So in section 4.2, we're going to continue working with data, and we're going to make scatter plots like we did in section 4.1. The data that we get won't fall perfectly on a line, so we won't be able to use the strategy of finding an equation of a line to fit the data like we did for the problems in section 4.1, but there is a line that fits the data as close as possible, and we're going to need to figure out how to find an equation of a line that fits a set of data as close as we can fit that line. And that's all going to be calculator driven. So in order to get started for this section, we need to get our calculators ready. And my old calculator works different than my new calculator. So let's get them both set up for what we need to do. Immediately, the first thing I'm going to need to do for both of my calculators is get something called Diagnostics turned on. For my new calculator, if I hit my mode button and I scroll down, there's a line that says set diagnostics off, set diagnostics on. I want to go over to on and hit enter. So when I hit the mode button, it better be the case that set diagnostics on is set up. Oh, it's not. Apparently my calculator is not that new anymore. It says 1615. I could have had it for 5 years. It's almost 2021 now, so it's almost 6 years old. Anyways, it's new to me, which means this is older. On this calculator, there's no easy way to get diagnostics turned on. To get them turned on, you hit the second button followed by the 0, which is the catalog key. So this is just getting your calculator set up for this chapter. So second and 0, and this is all the functions that are built into this calculator. This thing starts with a D. I have to scroll down for a lot. I just hold my little arrow down until eventually I'll get to the D's. There's diagnostics off, diagnostics on. I have my cursor on the diagnostics on, and I think I just hit enter twice. I hit enter once, and it says diagnostics on, and I hit enter again, and now they're on. So again, to do that on this calculator, second key, 0, which is catalog, scroll down, till you find diagnostics on, and hit enter twice. Enter and enter. Those could be on forever. You never need to turn them off. All right. So problem 2 gives me some data, wants me to make a scatter plot. Let's do that scatter plot of the data. So in my X's in list 1, I'm going to put the numbers 1 through 7. My Y's in list 2, I'm going to put the numbers 4, 10, 10, 13, 12, 20, and 24. Part of the reason I did this in the last section is just to make this section less calculator new. So on my calculator, to enter the data, hit my stat button, hit enter on edit. My list 1 has 1, 2, 3, and 4. I just need to add to it 5, 6, and 7. If I want to, I can clear out that list 2 by just scrolling up to the top, getting the L2 highlighted, hitting clear followed by enter. And in list 2, I want to put 4, 10, 10, 13, 12, 20, and 24. I can see I have a mistake because the 24 doesn't pair up with the 7. It needs to. My lists are unequal lengths. I'm going to get an error message if I leave this here. So 4, 10, 10, 13, 12. Oh, I see my list as errors here. It's supposed to be 1, 2, 3, 4, 5, 6, 7. The most common kind of error you can get is if your lists are unequal length. So make sure you get them to be equal lengths. So now when I'm done with this, I'll pull this off and get it going on this calculator. So on this calculator, hit my stat button, enter on edit. I have 1 through 7 on list 1. That's good. List 2 is 4, 10, 10, 13, 12, 20, and 24. If right now I did zoom stat, because if I turn my stat plot back on, let me turn it back on. So do second and y equals, hit enter on stat plot, enter on like we did in the last video. So again, that is second y equals, enter on stat plot, enter on. Now if I hit my zoom button and went down to the option that says stat, it's going to graph the data for me. The data isn't perfectly along a straight line, but we can find a line that approximates the data, and that's what we're about to do here. So for this one, if I did zoom and stat, that's creating a scatter plot of the data. And now I want to use the linear regression feature on my calculator to find the equation of a line that fits the data best, the equation of a line that I could use to make predictions beyond the data. So I drew this line here, and how do I come up with an equation for a line, and how do I get my calculator to graph it? That's what we're going to do next, and it depends on the technology that you own. So to come up with an equation for a line, which is the answer to part B. So for part A, I'm just going to say C calculator. I don't want you drawing any of these graphs by hand. It's just a nuisance, and it's not necessary to do any of the algebra that we're going to do. For part B, I'm going to come up with an equation of this line that we can use to make predictions about this data. And in order to do that, on both of my calculators, I hit the stat button. On both my calculators, I bump over to calc. Also on both of my calculators, I go down to number 4 and not number 8. That says linear regression. What this does is it finds an equation of a line that fits the data as closely as you can. So I hit stat, arrow over to calc, down to linear regression, stat, arrow over to calc, down to linear regression. Here's where the calculators work completely differently. So now I'm going to hit enter, and I'll hit enter. I don't know how well this is or isn't showing up on the screen. On my nice calculator, the newish one, the x's go in list 1, the y's go in list 2. I don't know what frequency list is, so I'm going to skip it. And I want to store the equation in y1 so it'll graph it for me. On my cheap calculator, it doesn't, well, old, it's not cheap. It doesn't say the list. So I need to tell it the lists. So after, on my older calculator, I hit the second button and the 1 key for list 1, and then comma, second button and 2 for list 2. Now we're kind of in the same place. We're doing linear regression. The x's are in list 1, the y's are in list 2. I'm going to hit a comma again on this calculator and say I want my list, the equation, to be stored in y1. For both of our calculators right now, where the cursor is blinking, I want to tell it I want my equation in y1. I do that by hitting the vars button, arrowing over to y-vars, hitting the vars button, arrowing over to y-vars, hitting enter when the calculator is on y-vars in function. So enter, and I wanted it in y1, so I'm just going to hit enter again. And watch what happens. Right next to my list 1, it gives me the y1. Again, to get that, you go vars, arrow over to y-vars, hit enter on function, and now I hit enter. Both our calculators are set up to work now. It knows that the x's are in list 1, the y's are in list 2. It's going to find an equation, it's going to put it in list 1 for me. When I hit enter, it's going to give me, when I hit enter on my old calculator, it gives me the equation. On my newer calculator, when I hit enter, I need to scroll down to calculate and hit enter. Now they both give me the exact same screen. Now they're working the same. It gives me the equation, and it tells me how good the equation is. So first of all, let me give the equation. I'm going to round to 2 decimal places. So it says the equation can be written in the form y equals ax plus b, where a is 2.92857. I'm going to round that to 2.93. So my equation I'm going to say y equals to, the number in front of the x is 2.92, and I'm just going to round to 2 decimals. So I'm going to say 2.93 times x. And then the number after the x is the b, like mx plus b, is 1.57. So both give me this. If I hit my graph feature right now, it's going to graph that line because it put the line into y1. So I have a perfect representation of what I have here. I've got the equation graphed. If I looked at my y equals, it snuck that whole thing non-rounded into my calculator. So I can find an equation of a line to fit any data. The question is the line worth using to make predictions beyond the data, or is the line kind of garbage? And this is where the R comes in on my calculator. The R tells me how good the data, how well the line fits the data. R is called a correlation coefficient, and the correlation coefficient it's a statistical technique used to measure the strength of the linear association between list 1 and list 2 for us. And it turns out that the number can be positive, the R, if the slope of the line is positive. The number would be negative, the R, if the slope of the line that is negative. R, the biggest R can be is 1. The smallest R can be is negative 1. If R is 1 or negative 1, it 100% goes through every point. There's not one point that's off the line. The further R gets away from 1, the worse the fit is. If R is absolute value-wise between 0.8, which means if R is between bigger than 0.8 but less than 1, or between negative 1 and negative 0.8, it's a really good predictor. We call it a very strong relationship. If R is between 0.6 and 0.8, absolute value-wise, it's reasonable but not great, and then it goes downhill. The smaller the R is, the closer R is to 0, the worse the relationship is. If R is 0, there's no linear relationship whatsoever. So, done with part B, I found my equation. Then it says, what's the value of R? I'm rounding everything to 2 decimals. I forgot to write this. And right here, my R is 0.94. That's a good R. Anything, if you take the absolute value, anything 0.8 or bigger, it's considered a very strong relationship. So how strong is the relationship? I'm just going to say it's very strong. It's probably a poorly worded question, but this is a very strong relationship, which means even though the data doesn't fall exactly on the line, this equation is good to predict with the data. For part E, it says if there's a very strong relationship, predict the y value that corresponds to x equal to 10. That's super easy to do. I'm going to use the equation, plug the value 10 in, and predict the y. So this is going to say y equals 2.93 times 10 plus 1.57. And I'm going to say it's going to be y equal to 30.87. If you're like a sig fig chem person, you might want this rounded to 31. I'm just going to round to 2 decimals for all the problems. But given none of the data had decimals, maybe it makes sense not to have an answer with data. Somewhere at the front of this section, I say round to 2 decimals mindlessly everywhere. That's everything there is for problem 2. Your problem 1, essentially exactly the same. Gives you a set of data, wants you to make a scatter plot, do the linear regression to find the equation of a line that fits the data best as possible, find the value of R, see if it's a good fit or a bad fit. If it's a good fit, plug 10 in to get an estimation for the point 10 comma what would be, what would you expect to come here. The list stops at 7, but we can predict what the y would be with 10, and this is kind of the most accurate prediction we can make. I'll do 4 with you. same keystrokes and do both calculators. So 4 gives me this data, wants me to enter the data, find the linear regression model, find the value of R, answer these questions. So let's get this going. First, I'm going to enter the data. How do I enter the data? I hit the stat button for each of my calculators. I hit my stat button and then hit enter. I kept the x's the same just to save me some nuisance. And in my y's, which go in list 2, I'm entering those numbers. Here in my y's, I'm entering the same numbers. If you get an error, 90% of the time, the error is that your lists are unequal lengths. So I have my data in. I could do a scatter plot just by going zoom and stat. And my scatter plot right now might have the fragments of that line. That's the line that we drew from last time. I didn't delete it yet. So this is a scattered plot with a line that doesn't at all fit the data. That's just a random line. And that line fit the last data, doesn't come anywhere close to fitting this data. So let's get a line on there that actually fits the data. That's what part B is. I'm going to do my linear regression, get a line that best fits the data, and I'm going to round everything to 2 decimals. How do I get the line? I hit my stat button. I arrow over to calc. I arrow down to linear regression. I hit enter. I hit enter. The only thing I need to do on my newer calculator is put into store regression equation y1 by going vars, yvars, function, and y1. Once I have it on this calculator, I'm just going to hit calculate. On my older calculator, I do second and 1 for L1, comma, second and 2 for L2, comma, vars, yvars, function, y1. Now they're both in the same place. On my old calculator, I scroll to calculate and I'll hit enter. On this calculator, I hit enter. Now they give me the same value. I'm going to round to 2 decimals for my equation. You'll notice that the R is negative. The reason the R is negative is because the slope of the line is negative, and not a bad thing. I just take I think of it absolute value-wise. I think of it as positive. I think of this R as 0.94, and anything 0.8 or bigger is considered a very strong relationship. 1 would be a perfect relationship, linear relationship. So when I go to answer part B, I'm just going to say y equals negative 7.6, round to 2 decimals, 8, x plus 48.57. For part C, R I'm going to round to 2 decimals, negative 0.95. And since absolute value-wise, the absolute value of that is bigger than 0.8, it's a very strong relation. And in part E, it wants me to predict at 10. If I hit my graph button, I'd see that line, how much better it fit than the last line. And that's all by hand. So I'm not graphing anything by hand because it's just too tedious and we don't need the graphs. Part E says if the relationship is very strong, which it is, predict the value when y equals to 10. It's going to be y equals negative 7.68 times 10 plus, I think there's a decimal there, 48.57. I'm rounding everything to 2 decimals, just going to live with that. I'm going to go negative 7.68 times 10 plus 48.57. And I'm going to say y equals negative 28.23 is what I'd expect my y to be for that data. So that's not really anything new other than having a negative r, but just getting us practice in doing the keystrokes. So this is your problem 3, should work the same way. Let me go and do problem 6 real quickly here, and maybe I'll just do one calculator. So create a scatter plot. I kept the 1 through 7 real nicely. And look, when I did my scatter plot, look how far the points are off the line. I don't think this is going to be a particularly good relationship, but let me see. Let me enter the data here. Seems like this calculator is working better. Stat, edit. I have the same x's just to save the grunge. So for my y's, 50, 100, negative 20, 200, negative 60, negative 30, and 0. So I have my data in. I could just go zoom and stat. That's a scatter plot for the data. There's my old line that I didn't delete. If I wanted to get rid of that, I could just hit my y equals button, clear that, and when I hit my graph, then I won't show that line anymore. So let me find the equation now. So stat, calc, linear regression. X is our list 1, Y is our list 2, vars, Y vars, function, Y1. So storing my regression equation and then calculate. I'm going to round to 2 decimals. Look at the R is 0.38. That's a poor relationship. 0.38, it says a moderate relationship, less than 0.4. So when I go to do part B, I'm just going to say Y equals negative 16.07, that's rounded to 2 decimals, X plus 98.57, again rounded to 2 decimals. And I'll say, just from this sheet, it's a moderate relationship. And then part E says, if there's a very strong relationship, use the line to make a prediction. So this time I can skip part E because this line isn't really very useful in predicting this data because it doesn't fit the data so well. Your problem 5 should be similar. Like I did the scatter plot, and you can see how far the lines are away from the data, so it's probably not a very good predictor. Maybe I'll stop and do a part 2. It just feels we're at 22 minutes and we're moving into another kind of problem, which isn't particularly different, but it's probably good for a break here.